Welcome back. Today's lesson is going to have implications. An implication statement is like a guarantee or a contract. Let's say rainy weather guarantees clouds in the sky. For which combinations of rain and clouds does this implication hold? Clearly, if it's raining and there are clouds in the sky, then the implication is valid. And clearly, if it's raining without clouds, then the implication has been violated. What if it's not raining? Since the condition is not satisfied, the result is irrelevant. These cases are called vacuously true. In either case, the contract has not been violated. Let's dig deeper into the meaning of the implication statement. In a statement, A implies B, we see anything is okay except when condition A is met, but the result B isn't. We can translate this into simple logical statements. We can then expand the brackets with De Morgan's law and simplify to give a simple expression. If A implies B, is the converse true? In other words, does B imply A? This is clearly not true. A simple counterexample is all that's needed. A square has four sides, but not every four-sided shape is a square. Two terms which get bandied around a lot in maths are necessary and sufficient conditions. Sometimes these terms are used individually, and sometimes a condition is both necessary and sufficient. Let's say a necessary condition for buying a Mac is having money. What is the implication? If someone buys a Mac, then we can infer they have money, or at least they had money. If a result is satisfied, we can infer that all the necessary conditions that led to that were also satisfied. However, a necessary condition alone may not be sufficient. Now let us say that scoring above 85% in all university coursework is sufficient to score a 7. In the Australian grade system, 7 is the highest that the grades go. This means that this condition alone will guarantee the result. However, it may not be the bare minimum necessary to get the result. For instance, scoring 100% is also sufficient to get a grade of 7, but not necessary. Conditions can be both necessary and sufficient. In this case, the left and right side of the implication are logically equivalent, as each side guarantees the other. The last thing we'll be looking at today is contrapositive. Let's illustrate this with an example. Say rain implies clouds. The contrapositive of this statement is no clouds implies no rain. It turns out these two forms are logically equivalent. Let's prove it. It takes a bit of fiddling around, but we get there in the end. Sometimes proving a statement directly is life-alteringly difficult. In some cases, the contrapositive might be an easier target to prove, and since it's logically equivalent, if we prove the contrapositive, we've also proved the direct statement. A lot of this stuff is still abstract right now, but over the past few videos, we've been laying out the really important building blocks of discrete maths. I hope you've enjoyed watching this, and I'll see you again soon. Bye!